Hi class, welcome back. So let's begin with section 3.5. We're going to introduce some business and economics applications that is related to calculus. So we're going to use this to solve and optimize problems in business and economics. And then in particular, we're going to find the price elasticity of demand for demand functions. We have talked about demand functions a lot, and so here's a great section where we actually explore more of the benefits of knowing the demand function. Um, so business and economics optimization. In this section, we're continuing on solving optimization problems. That is to maximize and minimize our business and economics problems. We're going to refer back to many of the results that we have obtained in previous sections. Some of these problems in the homework are similar to the previous sections. All right, so let's begin by defining price elasticity of demand. And we're going to do this by doing a discovery example, an example where we're going to help us explore these concepts. So we know that when price increases, of course, the demand will decrease. And what I mean by demand is what um, um, what the population is going to buy, right? So if the price increases, then the the population is willing to buy less. So that is that the quantity demand then goes down, right? We know that the revenue, by definition, is equal to the price times the quantity. So with the revenue go down, since the price increase, but the demand drops so much, or will the revenue increase because demand didn't drop very much? So what we're trying to ask the question is, how does that affect the price increase to the demand? Because if you increase your price and the demand doesn't change much, that means you're gonna increase your revenue. But if you increase your price and the demand changes a lot, in particular, right, it goes down by a lot, then we want to know how much is that going to affect the revenue, right? So it is a question of whether how much can the price be increased and how much is that going to change the demand, right? Well, that's the basic concept and the root of elasticity. Elasticity, if you guys think about it, is kind of like a rubber band, right? If you pull too much, right? Would if you change something, right? Would that make a big effect, or would it make a small effect to the demand? All right. So in this example, let's assume that we have a company that has a demand function of d of p, which equals 100 minus p squared, and the company's current price is $5. What will happen to the revenue if they raise the price by 5 cents? Well, we want to see how is that going to change the demand, right? So let's try to think about some of the concepts here. So we are more interested in how the price change compared to the demand change, right? So we want to compare the change in the price to the demand change, right? We want to compare those two. How is that going to affect? Is a small change in the price, would that be a big change in the demand? Or a small price change in price, will that be a small change in the demand, right? So we're going to convert everything to relative percentage, right? So a percentage of changes. In other words, so for example, for the price hasn't increased by, right? If we think about it, what is the change? Let me use the what is the change in price relatively to the original price, right? So remember that this triangle represents change in price. So for example, in this case, the change is this much relative to what? To the $5, right? So we if we think about this, the change over the original price, right? How much is that going to be? Well, it looks like actually like it's going to be just 1%, right? This is just 1%. The change of price over the change of the original price is just 1%. But now let's look at the demand. The demand decrease. We know the demand's gonna decrease because you raised your price, but let's see how that changes. So let's look at the demand. The demand at $5 at the original price, we can find it by plugging in 5 for p, so that'll be 100 minus p squared, which equals 75. To compare to what happens to the change price of 5.05, right? If you increase the price by 5 cents, then by doing direct substitution, we can find how much is that going to be the price of demand, right? Or the demand, which will be in this case 74.49. So the total change in this case will be 75 minus 74.49, and so that will equal to negative 0.5025. So this is the relative change, right, of the quantity relatively to the original quantity. The original quantity, right, was at the price of $5. We know that at the original price, we only had demand of 75 items. So the change that we had between those two is going to be negative 0.05025 over the original demand. So if we look at the change over the original demand, that's what we call relative change. And so that will give us a roughly, approximately negative 0.0067, or in other words, negative 0.67%, right? So if you notice, these are very small numbers, right? 1%, this is a decimal percent, right? Um, so what this means that if you raise the price, remember that negative means decrease, positive means increase. So if you increase the price by 1%, the demand will only fell by 0.67%, smaller than 1%. Since the price is increasing more than the demand falls, we would expect that the total revenue would increase. In this case, we said the demand is inelastic. It is inelastic because the change of the price does not affect the demand too much, right? It's going to affect it, of course, but it's not going to affect it too much, meaning it's inelastic. Right? They're not tied together too much. They're more loose, right? Their relationship is looser. Versus if there is a elastic, meaning a small change in the price will be a big change in the demand. So the elasticity of demand is measure of how demand reacts to the price change. And of course, we're gonna normalize this. This is normalized, which means that in the particular prices and the quantities don't matter, right? The price or the quantity doesn't matter, the units, and everything is treated as a percentage change. So let's follow the logic that we had before in the last example. We want to kind of create a formula for this, and so we're gonna use this opportunity to kind of create a formula for our class. So we want to compare, what we did up there was we want to compare the relative change in demand to the relative change in price. In other words, the demand in the change in demand over the regional demand all over, right, the change in price over the regional price. So what we're doing is we're comparing relative change of quantity over the relative change in price. So that's gonna give us, if we think about that as an approximation, the changes demand and price by the derivatives, right? If we think about that as a derivative, it kind of almost feels that way, right? That we have the dq over dq over q all over dp over p, which when you divide fractions, remember we can divide fractions by changing this into a multiplication by doing this times the reciprocal of the denominator. So that's the numerator times the reciprocal of the denominator. And if we notice and we arrange the order, we switch those two. Now we have P over Q times dQ over dP. But this one looks like just like a derivative, right? The derivative Q in respect to P. So that's actually what we're getting, right? So that gives us actually the elasticity function. So given a demand function that gives Q in terms of P, in other words, Q, the quantity, is equal to the demand function, the elasticity of demand is given by E equals the absolute value of this, right? Of this, which is this. So we put it right there. We're gonna put an absolute value. And if you notice, this is the derivative of Q with respect to P, right? The derivative of Q, which is this, with respect to P, right? So that's that one right there. This is this right here. And then since we already know that Q equals dP, we can replace this with dP. So what I'm saying here is this elasticity function, this ratio, is the same as this ratio. That P is this P. This derivative is this derivative now. The Q right there is this dP. So we have derived an elasticity function, and we're assuming that we're going to be given this function, right? And we're going to be able to take the derivative of it, and so on, right? So one more note: since the demand is decreasing function, right? Since the price is increasing, the demand is going to be decreasing. The derivative is always going to be negative. So that is why we have the absolute value. So E is always going to be positive because it's just a number that we can make that we can use. Basically, the business people wanted to just have a positive number, so they just convert that to a positive number, multiplied by a negative. So so we get this elasticity function, right? So the elasticity value is E, and can be found using this formula, right? This is a very preferred formula, and we use it often. So so these two formulas are equivalent, but this one is much easier for us to work with. So the following points summarizes the interpretation of E value with elasticity. If your E value, right, if this is less than 1, we're going to say that the demand is inelastic, kind of like the example that we had over there for the discovery. If this is the case, if this is inelastic, that means you should increase the prices. You should increase the prices because it's going to not the demand is not going to go down too much, meaning that that it's going to increase your revenue. Versus if your E value is greater than 1, then this is going to be elastic, and that means in this case raising prices will change a lot of your demand, meaning it will decrease your revenue. The other one will be, well, what about if we have E equals 1? Then we say that this is the unitary value, E equals 1, and we consider that to be a critical point of the revenue function. So critical point, that means that this could be a maximum or a minimum, right, for the revenue. So the interpretation of elasticity is that if we increase the price by 1%, just 1%, this means that demand will decrease by E%, right? Whatever the E value is. So E, this value is the percentage of change when you increase the price by 1%. All right, so that's it for this introduction. We're gonna jump into example